Hello, everyone. Welcome back. This is the Calculus 2. So in this video, we're going to talk about 2.7, integrals, exponential function, and logarithmic function. So, just a little bit of concept. Chapter 1 and 3, if you remember, we talked about a variety of techniques of integrals, depending on the function, such as a composition function, linear function, quadratic function, or radical function. We've been using different techniques of integral, and then in general you can find out all the techniques from the integral table in our module section, right? So if I just go to the Canvas quickly, so I want to share the techniques we learned. So if you go to Canvas and then click module, it's a little bit slower. So let me show you that table, where you can find out the table in our module. So if we go there a little bit slower, so just, yeah, right there. So we have a Math 3B. So if you click module, right there, integral table. So click. And then in this page, you have a lot of integral technique. For example, if you have a simple exponent, this is a general technique. You're going to adding the exponent plus 1 and divided by that. E to the whatever exponent, it's the same thing. And sign becomes a negative. So we've been learning many different techniques, correct? What we're going to do in 2.7, we're going to focus on especially exponential and natural log function and how to take the integral, okay? So we have so many techniques we learn, and then we're going to especially focusing on exponential and natural log. What if you have the kind of function, how would you be able to take the integral? So let's go to, that topic 2.7. So here, so let's talk about a little bit of recall. So if you have a simple x to the n, right? We are adding, the 1 and then divided by the exponent, and then you can find out the outcome. For example, fx to the third, you're going to take the integral. So you have 1 adding and divided by 4. So we know it is going to be x to the 4 over 4. So that is the outcome. And then if you have 1 over x, right? This is a very special. Many people think that -1, it's the same as 1 over x dx. And then x to -1 plus 1, oh, it's going to be undefined. So in this time, if you have x to the -1 or 1 over x, it is going to be ln x. You're not going to take the power rule in this function. So depending on the function, right? We have a to b dx, depending on this function. It could be linear, quadratic, poly, trigonometric. We have different techniques. That's what we have discussed so far. Here, 2.7, what if I have exponential, more complicated exponential and more complicated, log function? How would you be able to take the integral? That's a question mark, right? So we're going to focus on exponential and log. And here are the following properties. So we know that integral 1 over x is going to be ln x. So if you go back and forth, derivative and integrals are, the opposite relationship. So if you take ln x differentiation, you will go back to 1 over x. So this is so obvious. And then one thing, if you take the integral of ln x, since we don't know what the x, whether it is a positive or a negative, more specifically, there should be absolute value. So that's the property we're going to utilize it, and only the continuous function we can take the integral or the differentiation. So just keep in mind those are 3 properties. So I'm going to introduce more complicated form of exponential and log, and then we're going to take the integral. Okay, so let me just go down slowly. All right, so we have ln x. So just I'm going to write couple notes. Integral 1 over x dx, we know it is ln absolute value x, and then differentiation ln x, you're going to go back to 1 over x, right? So we know this relationship. So let's look at the first example. compute. So we're gonna take the integral when you have a function ln 3x second power minus 2x. What does it mean? You are going to take the differentiation, so d over dx, ln x. So we have ln 3x second minus 2x. So here, you have to check the structure of the function. So this function, you have ln function, right? ln x. And then 3x second minus 2x has been subbed into the ln x. So you have to think about what? Chain rule. So first, ln, take the differentiation ln, it is going to be 1 over x. So it is going to be 1 over, you know, what do you guys think? You're going to take the derivative. So ln 3x second minus 2x, you're going to have a 1 over x, 3x second minus 2x. This is the outside differentiation, outside differentiation. And then you have to take the inside differentiation. So that is going to be times, what do you guys think? You have to take the differentiation inside 3x minus 2x. Are you following? So this is the inside. So therefore, if you take the derivative, so 1 over x is going to be the outside differentiation. So 3x second minus 2x. Inside, 6x minus 2. So finally, 6x minus 2 over 3x second minus 2x. That's the answer. So this is the chain rule. First one, you're going to take the differentiation of ln x function. So that this is outside ln x function. And then you're going to take the inside 3x second minus 2x differentiation. So that we have to use a chain rule in this log function. So this is not simple log, a little bit complicated form of a log. So we've been using the chain rule in this concept. How you feel? It's a pretty understandable. We practice a lot. One more time. We have ln 3x n entire second power. So as you see that in this function, we are going to take the differentiation. So d over dx, I'm going to take ln 3x entire second. Wait. We have to see the structure of the given function. You have quadratic function. You have ln 3x function. You have inside 3x. This is a sub there. This is a sub there. So this is a couple double chain rule, as you see that. So therefore, you have to do inside, middle, and outside. Separately, you're gonna take the integral differentiation. So first, the outside, I'm gonna bring. So this is the outside. So this is the outside. I'm gonna change the color outside. So this is going to be, you have a 2 ln, right? 2 gonna bring to the front, ln 3x, and then you have a 1 remaining. So 2 times ln 3x, this is outside. Inside, what happened? The inside is gonna be ln 3, right? ln 3x, so you're gonna take the derivative, ln 3x, and then this is the middle one. And then the last one is going to be 3x. You have a last one. So d over dx, 3x, this is the last one. Are you following? So this is outside, middle, this is inside. So once you take the integral, that is going to be 2 times ln 3x. ln 3x, when you take the integral, this is going to be 1 over 3x, and 3x will be 3. So therefore, 2 ln 3x, 3 cancel, over x will be your answer. So this is a chain rule of more complicated exponential and log function. We're gonna do the integral soon, but let's take a look at it first. Okay, so I think you guys are doing awesome. Okay. All right, let's take a look at one more problem. Here we go. Now this is an integral question. You see that? We have integral symbol. And then this is, we have x over x to the second plus 4 dx. So something, you can think about the u substitution. Look at the denominator. So u equal to x second plus 4. So if you take the du over dx, will be 2x. So du will be 2x times du. Always we want to find out x times, x times dx. So I'm going to modify. We're going to divide it by this, 2. So that would be du over 2 will be x dx we're looking for. So therefore, 1 over u, right? And then x dx, that has been x du. We have a 1 over 2 du, correct? So x times dx is a 1 over 2 du. So this one, dx, x times the dx, and we have a 1 over u. So what happened? 1 over 2 u du. I have a 1 over u, so my bad. So here 1 over u du. So this is the technique we learned, ln x. 1 over 2 ln u plus the c. You can go back to the u in terms of the x variable, x second plus 4 plus the c. So we practiced the chain rule in calculus 1 and 2 in many times. We are just a little bit complicated form of the exponential and log function. So in this video, we're going to practice a lot of, integral techniques with the complicated exponential and log. Let's take a look at the following question. So same thing. The denominator, you're going to set up the u. This is a complicated, function. So let's u sine x. So du over dx cosine x if you take the derivative. So du will be cosine x dx. And I got it, cosine x times dx. That's du. So therefore, integral 1 over u, that is going to be du. Again, you're not going to use a power rule. This is automatically ln u, correct? So many people make a confusion. 1 over u, take the integral, it's ln absolute value. You can go back to the x variable. So sine x plus the c. So that's the answer. All right, how you feel? Getting better. I'm going to keep bring this one because this is used a lot. Copy, paste, right? All right, let's keep going. Second question, tangent x. So same thing, actually we did this question, but let's try it again. Tangent is the same as what? Sine x over cosine x dx. Again, you're gonna set up the denominator, u. So du over dx, that is a negative sine x. So du will be negative sine x dx. We need a what? Sine positive sine x dx. I'm going to divide it by negative both of sides. So positive sine x dx will be negative du. So what happened? This will be integral 1 over u, and then sine x dx will be negative du. I'm going to bring negative to the front. Again, 1 over u, this is going to be ln u. And then you can go back to the u was a cosine x. According to the exponent property, you can bring this one to the front as to the exponent of cosine x. So which means if we did this one, ln cosine x negative 1 plus c. Cosine x inverse, that is the same as secant x. So that if I remember, we talked about this 1 over cosine x, which is a cosine inverse x. It is the same as secant x. So that's why you have this answer. So we already know how to do it. The reason why I'm showing you this one, because many people don't know what is the integral of 1 over x, 1 over u. It's going to be ln, okay? So take a look at that example. So that was the basic question in terms of the exponential and log. Let's keep building more concept. Okay, I'm going to go down slowly. So here I have a couple recall. So you learn these property in pre-calculus. Properties of natural log. Let's quickly check. ln 1 is going to be 0, correct? And then if you have a, b, you can separate it as addition. Am I correct? If you have a fraction, you can separate it as a subtraction. And then the exponent, you can bring it to the front. So these are the basic property of exponential or log function. So I just want to tell you one more thing. Log base x, it means base is b as a number greater than 0. If you have a ln x, that means base is invisible e. There's an invisible e. So that's the difference. So we call the log base x, this one we're going to call log function. If you have a base is e, we call this is a natural log function, just different name, if you remember. Okay, so based on this recall, just quick check. ln 9 minus 2 times ln 3, ln 1 over 3. So I want to compact, I want to condense it. So since it is ln, you know that the base is going to be invisible e. There's an invisible e. So we have a same base, you can combine it. So that would be ln 9. So we have ln 3. You can bring 2 to the front, to the back as a second power. And then ln 1 over 3, you can subtract ln 1 minus ln 3, correct? And then let's rewrite it. ln 3 to the second is going to be 9. It is ln 1 minus ln 3. They're going to be canceled. Ooh, what did I say ln 1? It's a 0. So 0 minus, this is a 0. We have ln 3. Again, you can bring negative 1 into the exponent. It's going to be ln 1 over 3. So you can think about this logic by using the exponent and log property. We learned this one in pre-calculus. Just I'm going to recall because we're going to utilize it. Okay, so that should be okay, right? Couple more property you already learned in pre-calculus. So this is the log, and let's talk about the exponent. So let me go down here. The property of exponential. So this is another recall. I'm not going to really emphasize on. So you can, if you have a same base, you can adding up. If you have a same base, you can subtract. You can double multiply if you have a parenthesis. So this is exponential rule we already learned. So these are 2 recall pages. Okay, I'm not going to really emphasize on because we already learned this a long time ago. So based on this concept, what we're going to do, I want to know how to take the differentiation or integral, isn't it? So here is the important property. We know exponential e to the x, you're going to take the differentiation. It's the same thing, correct? What if I have differentiation a to the x? It's not the exponential, the base is a constant. And keep in mind, it is going to be ax. You're going to keep ax times ln a. This is the second property. I'm going to introduce 1, 2, 3, 4, 5, 6. And then if you have ax integral, this is the opposite. This is integral. And then it's going to be 1 over ln a times ax plus c. This is the technique you're going to use. Okay. You're going to keep ax and 1 over ln a. And then differentiation of log base x, it is going to be, you have x times ln b and then divided by from 1. That's the differentiation. Sometimes you will see the sum, but that's okay. E to the u is always the same, e to the u. then you're gonna take the derivative of the inside subfunction. Okay, and then AU will be AU times ln A. So this is something is new in not part of in calculus, pre-calculus or calculus 1. So this is going to be given in your table. So just e to the x is not equal to a to the x. This is base is always e. This is base is always greater than 0. It's some constant, right? So if you have integral e to the x dx, it is going to be e to the x. If you take the ax integral, look at number 3, it is going to be ln 1 over ln a times a to the x. So they are different, okay? So check it out. We are talking about the differentiation and integral with a little bit complicated form of the exponential function, okay, or log function. And sometimes you have a chain rule as well. So these are chain rules. So I will show you the example. So all the formula will be given in your table. So I already copied here. So let's take a look at this question. I want to take the derivative e to the 3x times e to the tx, correct? So first of all, this is the same base, which is e. So I can adding them up. So d over dx, e to the 3t plus t to the second. Are you following? So now in this structure, you have a two function. What happened? One is e to the x function. 3t plus t to the second has been subbed into the x. Dun, 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 dun. This is a chain rule. So therefore, you're going to do step-by-step work. I'm going to make a little bit smaller. We're going to do the step-by-step work. So what happened? You're going to take the derivative e to the x first. So e to the x outside. So it's going to be the same. So you're going to keep e to the 3t plus t to the second because it's same. But then what happened? You're going to take the inside. 3t plus t to the second has been subbed. So that we're going to do d over dt. 3t plus t to the second, take the derivative. So therefore, e to the 3t plus t second, and this one will be 3 plus 2t. So the final answer, I can change the order. E to the 3t plus t to the second will be the answer. So this is a chain rule. E to the x form and 3t plus t to the second has been subbed. So as you see that, this is outside, this is inside, derivative. Outside, this is inside. Gotcha. Same strategy, the number 2. We have this one, I see e to the x and 3x second has been subbed. Chain rule. So you're gonna do, keep it, e to the 3x second. This is the outside. And then you're gonna take the derivative inside 3x second, correct? So therefore, e to the 3x second, this is going to be 6x. In other words, 6x times e to the 3x second, that's your answer. So this is inside and outside chain rule. Okay, so we are getting better and better. I'm gonna do more complicated works. So let's keep going. So example here. We wanna take the integral 2x times e to the negative x second dx. So first of all, I see the exponential e to the negative x to the second. So here I have a two structure, e to the x, right? And then what happened? Negative x second has been subbed e to the x. Definitely we're gonna use a chain rule. So we have to use a substitution, use substitution, because the negative x to the second has been subbed. And then later you have to find out 2x and dx in terms of the u variable. So let me start here. negative x to the second has been subbed into e to the x, correct? So therefore, let u negative x to the second. So du over dx will be negative 2x. If I just du equal to negative 2x du, very close to 2x and dx. So divided by negative 2x du. So we found that they're equal. So what happened? This one now, integral e to the u, correct? U is negative x to the second. And then 2x times dx, that is negative du. So I can bring negative to the front, e to the u, du. If you take the integral, e to the u is going to be e to the u. And plus the c, I can go back to u was negative e to the negative x a second plus the c. There we go. That's your work. So in this question, you are using u substitution, and you're gonna use a chain rule both. So this question, u substitution and chain rule, we use both in terms of the exponential function. So we never know what kind of structure of the function you're gonna deal with. So the best way is to practice. So I will show you more and more work. Okay. So let's take a look at one more complicated function. Here we go. Ooh, all right. Let's take a look at it. So this is a 4 and 2. You feel that there's a common factor, which is a 2. So let me modify. D over dt, 4 is the same as 2 to the second, correct? And then 2 to the t to the second. Now you have same base. So we have a 2 to the 2t plus t to the second. We can adding them up according to the exponent rule. We just recall all of them. So what happened? You see the structure? What happened? In 2 to the x, and then 2t plus t to the second has been subbed into the x. This is chain rule. So you're going to step by step work. This is second case. This is not the e, this is a constant. So when you take the derivative with the exponent with the base equal to a, it'll be outside will be, you're gonna keep 2t plus t to the second. This is outside derivative, correct? And then inside, what happened? You're gonna take the derivative d over dt, 2t plus t second power. Correct? So that would be, oh, actually, I forgot something. So let me move this one. Before I'm going to do, I forgot ln a. So ln a is what? 2. So what I'm saying is, this is entire outside differentiation, correct? So 2, this one is d over dt 2t plus t to the second. Correct? And then you have to take the inside. This is inside derivative. Yeah? So be careful. This is outside and this is inside. So therefore, 2t plus t second, ln 2, and this is going to be 2 times 2t. So finally, you can change the order, 2 plus 2t, and then 2 to the 2t plus t second, ln 2. So that's your final answer. So be careful, take the derivative outside, which is outside, and inside 2t plus t to the second. So this is very important technique you're gonna think. All right, one more. Okay, so this is log function. So as you see that we have a 2 structure, log 8 function, and 7x a second plus 4 has been subbed. This is another chain rule. So I'm going to take the derivative outside. So log, if you have the last one is here. If you have a log base x, your outcome is going to be 1 over x ln b. So this is going to be your x. So we have a 1 over 7x a second plus 4, right? And ln b is 8. So this is what? This is exactly outside derivative. Are you following? So this is the outside. And you have inside. So now you're going to take the inside 7x a second plus 4. So 1 over 7x a second plus 4. I'm going to just make a parenthesis so we're not going to be confused. ln 8. And then this is 14x. That's it. So finally 14x over 7x a second plus 4 ln 8. So that's your final answer. So that is outside and inside. Chain rule. Better? So that's actually 2.7. Not that complicated. 2.7 is a very, very understandable topic. You are practicing how to take the derivative and integral when you're dealing with the complicated exponential and log function. I'm going to just do a couple more questions from our quiz 2.7. I want to help you guys. So let's take a look at 2.7 quiz as a question. So we have all the formulas right there. Okay. So now you have a better confidence. So we have 8x times ln x. So this is a little bit complicated. We have a log and we have a linear function. And then two functions are multiplication to each other. What do you guys think? This is product rule. Do you remember? F times g, you're going to take the derivative, f prime g plus g prime f. So therefore, I'm going to set up f is going to be 8x. So f prime will be 8. G function is ln x. What is a g prime? Ln x will be 1 over x. So therefore, f prime g plus g prime f, f prime 8 times g ln x, g prime 1 over x, f is 8x, correct? So if you simplify x gonna be cancel. 8 ln x plus 8, I can combine 8. So ln x plus 1, that's your final answer. Getting simpler, right? So in this question, we don't use a chain rule because nothing has been subbed. 8x is a separate function. Ln x is a separate function. They're multiplying to each other. So therefore, you use a product rule only. So please check the structure of the function. What function, what kind of function you have, and what is their structure, okay? All right, let's take a look at the second question. Oh, check the structure. We have something to the fourth quadratic function. It's like a fourth power function, and then ln x function, x plus 1 has been subbed. So you have 3 functions all together. Oh, we're gonna use a chain rule, definitely. Sub. So step 1, d over dx, ln outside, this is outside function. You're gonna take the derivative inside function. You're gonna take the derivative, this is the middle, and inside is x plus 1. So you see that? Outside, this is the middle, this is inside. So therefore, this is going to be 4 to the front, ln x plus 1 to the third. This is what? ln, right? This is ln. ln x, this is going to be, if you remember, d over dx 1 over x is ln x. Or if you remember ln x, it's going to be 1 over x. So therefore, this is 1 over x plus 1. This is going to be 1. So finally, for ln x plus 1 to the third over x plus 1, that's your final answer. So check it out, the structure of the function, okay? Okay, I'm gonna do a couple more. This is a quiz of 2.7. I'm trying to help you guys. Okay, this is also chain rule. Don't you see that? So why? I see ln x, radical x, right? This is we have ln x function, and then you can have radical function, right? Has been subbed into the, into the ln function. So what I'm saying is, if you feel confused, we can just think about it, equal d over dx ln 5x plus 3 to the half exponent, because the radical is a half exponent. So now you see that ln function and 5x plus 3 has been subbed there. So what I'm saying is outside and inside. So we're going to do d over dx ln 5x plus 3 to the 1 over 2. And then inside, we have 5x plus 3. So you have outside derivative, inside derivative. So this is 1 over 2 ln 5x plus 3, 1 over 2, minus 1, right? You can bring it and then you can subtract that. So that would be minus 1. And this is going to be just 5. So once you get it, I think I have a little bit of problem. What's my problem? Because if you remember, I can actually, this is a complicated one. So let me redo it from here. So what I'm saying is, because this is something we can use the log property. So log, if you remember, or ln b to the n, you can bring n to the front, right? So they are equal. I can bring 1 over 2 to the front of the ln. So it is actually same as 1 over 2, correct? D over dx ln 5x plus 3. So this is better to take the unequal, and this is going to be 5. This is inside, this is outside. Are you okay? So now this is a simpler. 1 over 2 ln 5x, what happened? It is going to be, just 1 over 5x plus 3 times 5. So we have 5 over 2, 5x plus 3 will be the answer. And now they want you to when x equal to 1. So plugging in 5, 2 times 5 times 1 is 5. So it is going to be 5 over 8 times 16. So that's your answer. Okay? So think about it. This is not really complicated. You can do this question. Okay, so likewise, let's try to one more. So here, what do you guys think? See the structure. You have ln x function, 2x second, 8x plus 4 has been subbed. So what are you going to do? This is inside and outside again. So d over dt. Actually, this one should be x because we have to get the same. So let's say this is x. So my bad. So d over dx outside ln 2x second minus 8x plus 4 inside 2x second minus 8x plus 4. So as you know, this is outside, this is inside derivative. Are you guys okay? So now this is going to be according to the ln x, it is going to be 1 over 2x second minus 8x plus 4. And then this is going to be 4x minus 8. So you can simplify 4x minus 8 over 2x second minus 8x plus 4. You can factor x minus 2. Bottom common factor is 2. And then actually when I factor out 4 and 2, so they're cancel 2x minus 2 over x second minus 4x plus 2. So you can find out that answer. So check 2.7 quizzes. I put many different type of function. So definitely you're gonna check the structure of the function. That's important. Okay. So one more, I think 2.7 here. What do you guys think? Oh, actually here, they were looking for f of 2. Now you're gonna plug in 2 here so you can simplify that answer as well. One last one, check the structure. We have ln x function and 5x to the third has been solved. So d over dx ln 5x to the third, outside, inside, outside, inside, right? So what happened? This guy will be 1 over 5x to the third. This guy will be 15x to the second, correct? So you can simplify. 3 over x will be the answer. And when x equal to 1, so that f of prime 1 will be 3. So you can finish all the quizzes, 2.7. I pretty much show you all the work of a couple 2.7 quizzes, so you can master that concept. So 2.7 is a not really complicated one. You already know all the integral techniques, such as a chain rule, use substitution. Just we're dealing with a complicated exponential and log function. And then just keep in mind those techniques as well, so that you can simplify how to take the chain rule and use substitution as well. So that's a 2.7, yes. So we have a one more unit in chapter 2. So that's gonna be 2.9, very short video. So we're gonna finish up chapter 2, okay? So I will see you guys in the next video. Thank you for watching. See you soon. Bye-bye.